Hello everyone. Welcome to the seventh behavioral health lesson. In today's lesson, we will take a look at learning. First, we'll discuss classical conditioning, then we move on to operant conditioning, and finally, observational learning. So here are some basic terminology about reflexes and instincts. There's an important distinction, which is that reflexes are involuntary automatic responses to stimuli. The mechanism is that it's controlled by the spinal cord and it bypasses the higher brain centers. Essentially, it's very fast and autonomous, but it's also inflexible. For example, goosebumps are basically useless now, but we still have goosebumps even though they no longer serve their original purpose. Meanwhile, instincts are inborn behavioral patterns triggered by environmental stimuli. For example, contagious yawning in humans is possibly linked to empathy, and parenting behaviors, like a mother dog licking her pups clean, is a matter of instinct. The complexity is that it requires more neurons than the reflexes, and it does involve the higher brain areas beyond the spinal cord. Learned behaviors result from experience and practice. Some examples are language acquisition, the ability to use tools, or learning to play an instrument, or learning to play a certain sport. The features of learned behaviors are that they're more flexible than reflexes or instincts, and they vary across individuals and cultures. It has interactions with instincts. For example, many instincts actually help the learning process, notably imprinting in swans, which is basically a child copying the mother, allows it to pick up abilities and certain necessities in order to survive. The evolutionary significance is that indeed it is essential for survival in changing environments where you might not have the time to pick stuff up on your own and you just need to rely on mimicking the rest of the pack. Associative learning is a type of learning where you form connections between stimuli and behaviors. There's two types, classical conditioning and operant conditioning. Classical conditioning is where you associate one stimuli, which is inborn and natural, with another stimuli, which is not as natural. Operant conditioning is an association between behaviors and their consequences. Both are important because they help predict future events based on past experiences. For example, bees associate flowers with nectar, and humans learn that practice improves skills. Actually, to clarify the last slide, the learned behaviors do not just need to uh, be mimicking. They can also be of a associative learning or other types of learning. Observational learning is indeed one of the types, but we'll talk about that later. Non-associative learning is where changes in the response magnitude to a single stimulus. So basically, you have two types. First, you have habituation, which is decreased response to repeated stimuli. For example, if you walk into a hotel and you stay there for a few days, you'll get used to the noises. Sensitization is where you have an increased response after a strong stimulus. For example, heightened alertness after an earthquake. The role in prioritizing, so the benefit is that it helps you organize a prioritization for what you want to pay attention to. Habituation filters out irrelevant stimuli that you need not pay attention to, whereas sensitization prepares for potential threats. First, classical conditioning. So, a psychologist named Ivan Pavlov, as the story goes, noticed that dogs salivated to signals predicting food. For example, if the lab assistants entered the room, and even if the dog couldn't see the food in their hands, they knew that the lab assistants probably did have food and automatically associated the lab assistants with food. So Pavlov defined associative learning between a neutral stimulus and an unconditioned stimulus. The unconditioned stimulus was the food because it makes the dog salivate, which is the unconditioned response. The conditioned stimulus, which he used in his experiment, was a metronome sound. So basically, what he did was right before offering food, he would play a metronome sound, and then the dog would have to associate the metronome sound with food that is about to come. And the conditioned response is that even when there is no more food, and the dog will immediately salivate just when a metronome is present. The significance is that this forms the basis of emotional responses and therapeutic interventions. So here is a schematic diagram of the process of Ivan Pavlov's classical conditioning. There are a few phenomena that you need to understand. Acquisition is the gradual development of the conditioned response, like salivating to the metronome, through repeated pairings of a conditioned stimulus and the unconditioned stimulus. Contingency is the fact that the conditioned stimulus has to reliably predict the unconditioned stimulus in order for strong learning to occur. A dog learns to associate the bell with food or a metronome only when the bell consistently precedes the food. That's acquisition. Extinction is when the conditioned response, right, the salivation to the metronome, decreases when the conditioned stimulus no longer predicts the unconditioned stimulus. For example, if you keep having the metronome or the bell, but you no longer give the dog the food right after. Spontaneous recovery is where, after extinction, if you wait it out for a certain duration of time, it's as if the extinction never happened and the dog is right back to associating the unconditioned stimulus with the conditioned stimulus. The significance is that extinction is a new learning process, not simply forgetting. And here is another schematic diagram showcasing continuity and contingency, as well as contiguity and less contingency. Next, we have generalization, which is where the dog responds to similar stimuli in the same way. For example, let's extrapolate and say that we take humans, right? Maybe you're scared of bees. You had a traumatic experience with bees. Well, maybe afterwards you'll also have a fear of wasps because they look rather similar. Discrimination is where you learn to differentiate between stimuli. For example, salivating only to a specific tone of the bell or a specific tempo of the metronome. For example, you could also consider, for example, a veteran distinguishing gunfire from car backfires, right? And higher order conditioning is where a conditioned stimulus can be associated with additional stimuli, eliciting the conditioned response. It's as if you're layering one classical conditioning with another classical conditioning, where you turn the bell or the metronome into the unconditioned stimulus, where it already naturally, strongly is associated with the dog salivating. Now let's introduce another conditioned stimulus, pair that up with the metronome, and try to see, even when there's no food, try to see if the dog can salivate with with this new conditioned stimulus. The practical application is that with all of these layerings, you can sometimes have these unreasonable phobias and prejudice. Inhibition is a process in which a conditioned stimulus signals the non-occurrence of an unconditioned stimulus. It helps organisms predict safety or the absence of danger. For example, zebras learn that a relaxed lion is less likely to hunt, so they're less wary of the lion. Equipment gauges in the green zone indicate no immediate risk of malfunction, so humans, when they see this, right, for example, on construction sites, you'll be less wary and less precautious, and instead focus on other potential threats to safety. It reduces unnecessary stress by teaching organisms to respond only to reliable signals, and it's used in rehabilitation programs to help addicts associate certain signals with the absence of drug availability. This is very effective because, unlike simply just abstaining from the drug, where you still have the impulse of taking the drug, here you're saying that, well, the drug is not going to be accessible, so you might as well not try. Latent inhibition is when slower learning occurs when a conditioned stimulus is already familiar compared to when the conditioned stimulus is novel. The familiarity with the stimulus reduces its ability to form new associations. A person who frequently eats pizza without issues takes longer to associate it with illness after one bad experience. Similarly, actually, on the other hand, rapid aversion to novel foods like chocolate covered insects, after a single illness, you'll be able to associate those two things immediately. It prevents the overgeneralization by focusing learning on novel and potentially significant stimulus. It helps explain phenomena like creativity, where reduced latent inhibition allows for novel associations, and schizophrenia, making far-fetched, inappropriate connections that don't make sense at all. There are actually biological predispositions that affect learning. There's a very famous example, which I'll cover right now, was done in an experiment by Garcia and Kohling in 1966. Basically, Pavlov had this idea that maybe we could pair all unconditioned stimulus with conditioned stimuli. This is not true, right? Because of the last slide where you have latent inhibition. The rats associate taste with illness more readily than visual stimuli, and birds with better vision associate visual cues with illness. So, what they did was they exposed rats to tasty water, and they learned to avoid it after they got ill. Whereas they had also a thing called bright, noisy water, where they shine a light and made a sound after the rats drank plain water, and this was more easily associated with an electric shock. The significance is that it challenged Pavlov's assumption of interchangeable stimuli, which is the theory, the idea that every stimuli can be conditioned. The Rescorla-Wagner model is where learning depends on the surprise or the novelty of the conditioned or unconditioned pairing. So stronger learning occurs with unexpected pairings. If a person already associates peanuts with illness, then they won't form a new association between the illness and the peanut containing protein bar. So this introduces cognitive elements where the person needs to actively think through the stimulus in order to pair them up. And here is a diagram showcasing uh, how an increased number of trials will reduce the association. So this type of classical conditioning is used in therapeutic applications for phobias, which we've already discussed. For example, if you flood a patient with a phobia, you treat the phobia by exposing the individual to something that is fear producing, but then with no actual consequence, right? Because it's a phobia, so it's irrational. So nothing's actually ever going to happen to them negatively. And then basically they'll associate the lack of the lack of danger with this phobia, with whatever they're scared of now, which makes them less scared, thereby removing the phobia. Counter conditioning is where you replace the undesirable conditioned response with a desired one. For example, if you associate a rabbit with a pleasurable activity like eating to reduce the fear of rabbits. Systemic desensitization is where you gradually introduce a fear such that the patient slowly realizes that there is no harm. Aversion therapy uses counter-conditioning, remember that term, to replace positive associations with negative ones. For example, if you make cigarettes taste not so pleasant, and that would aid the patient in the cessation of smoking. So, continuing on with addictions, right? So, environmental cues associated with drug use elicit cravings, even in the absence of the drug, which is something that we've talked about before. So, but this challenges this has a challenge because naturally, when the patient tries to abstain, they'll still have the cues there, right? There are smells and places and people that are linked to the products that they may consume. So there is a lack of extinction. Whereas if you have these, with this classical conditioning, you're able to remove the urge. It's also an explanation for the placebo effect. Because, for example, Pavlov's dogs showed pain relief when entering a lab previously associated with morphine injections. The implications are that the placebo effects can reinforce belief in ineffective treatments, and it can result in overprescription of unnecessary medications. So here is a summary of classical conditioning. We have terms: acquisition, extinction, spontaneous recovery right after the extinction, as well as inhibition, generalization, um, uh, discrimination, higher order conditioning, as well as latent inhibition. Second, operant conditioning. So here's Thorndike's law of effect and the Skinner box. Basically, behaviors followed by satisfying outcomes are more likely to be repeated. Consequences shape behavior. That's how you'll memorize it. And Thorndike, he made a puzzle box where you put a cat inside, and there was only a lever which opened the door for escape, and outside there was food to motivate the cat to open the door in the first place. Skinner took that to a much more advanced, complicated level where there was a much more controlled environment to study operant conditioning. For example, rats pressing a lever to get food. What you see on the right is the Skinner box. So here we're talking about voluntary behaviors and intentional actions, unlike classical conditioning, which is just association of different stimulants. So there's a method of successive approximations where to increase the frequency of behaviors that you want, first you let it be for some behaviors which are close enough. You reward behaviors which are close enough, and gradually you get more strict, and then you expect the participant, the learner, to have behaviors which are closer and closer to the end goal. This is common in dogs. For example, if you want to teach your dog to bark, maybe you'll lure them with food. First they whine, and then you reward them with the food. And then progressively, you expect the dog to make louder noises, which eventually turns into a bark. There are four types of consequences. To increase behavior, you will reinforce the learner. You either have positive reinforcement or negative reinforcement. Positive reinforcement, you add something good. Negative reinforcement, you remove something bad. If you want to decrease behavior and punish the learner, a positive punishment would be adding something bad, whereas negative punishment would be removing something that is good. For example, grounding the learner. There are a few miscellaneous terms which I also want you to understand. The Premack principle is basically whatever behavior an organism spends the most time and energy doing is likely to be an important behavior. A conditioned reinforcer is a reinforcer that gains value from being associated with other things that are valued. It is also known as a secondary reinforcer, like money or grades. What do they do for you personally? They actually have no benefit, but because they're associated with things that are much more beneficial, for example, whatever in your psyche that motivates you to get good grades, for example, approval or self-satisfaction, or potentially a higher chance of getting into a program that you want to get into, right? These are primary reinforcers, whereas the grades themselves would be the secondary reinforcer. It's a signal of approval that lets the subject know that their actions are correct. Latent learning is learning that occurs in the absence of reinforcement, and instinctive drift is where sometimes you may have a combat between what you want the patient to learn and the patient's biology. There are a few schedules of reinforcement for operant conditioning. It's a rule stating which instances of the behavior will be reinforced with a reward, because Because who says that they have to be rewarded every single time, right? It's defined in terms of the time and the number of responses required in order to present or remove a punishment or reinforcement. Continuous reinforcement is reinforcing a behavior every time it occurs, and partial reinforcement is forcing the desired behavior on some occasions. Fixed ratio is where you reinforce uh, every time for a set of number of behaviors. For example, every 3 times the learner does something, you reward them. Variable ratio, for example, you have an average of 10 times and then you reward the patient, but it doesn't have to be 10 times. Maybe they do something 7 times and you reward them, and then the next time they have to do it 13 times. And then you have fixed interval schedule, which is basically the time that must pass before reinforcement becomes available following a single response that's set to a certain amount. For example, the dog must wait 5 seconds after doing a trick to get a treat, whereas variable interval schedule is basically the first response following a varying period is reinforced. Maybe the person does something correct, and then you wait maybe 3 seconds, maybe 10 seconds, maybe 50 seconds or a few minutes, and then you give them the reward. So there is a significant effect where variable ratio learning is the most effective, and slowly and then you have fixed ratio, variable interval, and then fixed interval. So variable ratio is the most useful if you want to learn at the fastest rate. So here are all of the schedules in one cohesive table. So now we talk a bit more about secondary reinforcers. If they're used on a wide scale, they're called a token economy. You can also have menu approaches, for example, employee benefits, which allow workers to choose benefits that match their needs, which increase motivation. Right? The menu would be the token, and then their own benefits, their own chosen benefits, would be the actual intrinsic reinforcer to them. Teachers often use token systems in earlier grades, like stars or tickets, to motivate students, and at the end of the year, they may offer them rewards like candy for whoever has the most circles filled out because they did something the most amount of times. It's effective in prisons and institutions for individuals with intellectual disabilities or mental illness in order to reinforce good behavior. This is also used in behavior therapy, right? So it includes extinction, reward, and sometimes punishment. It's used for substance abuse patients, right? Where you use operant conditioning techniques such as reinforcement and punishment. There's also cognitive methods which you can pair up. For example, behavior therapies are often combined with cognitive methods to address both the behavior and the thought pattern to treat the disorder, right? So if you remove the bad thoughts along with the bad action, then that's the most effective. This is used in autism treatments, disorders like depression, and other intellectual disabilities. While you may not be able to cure the disorder, you're able to significantly improve the level of performance and functioning. Finally, we have observational learning. And so quickly, let's go over the Banderas bubble doll study. Children were observing adults interacting aggressively or non-aggressively with a bubble doll, which you can see on the image to the right. The findings were that the children imitated aggressive behaviors which they observed. Now, you needed 4 necessary cognitive processes in order to successfully get the children to model the adult's behavior. First, attention to the adult doing the thing, the retention, the memory of the adult doing the thing, the ability to reproduce the action, and finally, motivation. The implication is that you can learn without direct reinforcement. Imitation was more likely when aggression was rewarded or left unpunished. We also have mirror neurons, which fire both during action performance by the person and observation of another person. It had a hypothesized role in empathy and learning by imitation. It's recently been proven to exist in humans when measuring neurons under anesthesia during seizure surgeries, because otherwise it'd be quite invasive. Psychologists and physiologists knew that there were mirror neurons in monkeys, but only recently did they also confirm that these things did exist in humans. So the implication is that you learn social behaviors through observation, maybe through mirror neurons, and that's the hypothesis. So imitation in general, right? Going back to one of the earliest slides, it's observed in various species of animals. There are many adaptive advantages. The benefit is that uh, you don't. It saves quite a lot of time. If the rat is able to see, in a comical example, that bar pressing for food more quickly, that bar pressing for food is a good idea, right? If they see another rat bar pressing for food and they receive the food, then it saves the time, and the rat itself doesn't need to think about how do I get this food because they already know how. They've already seen the action being done by another rat, and now they'll just imitate the action and get the same results. It's also good for fear learning. So monkeys can quickly learn to fear snakes if they observe another monkey displaying fear. There's also some implications in facial expression, right? So if you imitate facial expressions, that's a key element in developing empathy, especially in humans, and for autism. So the individuals with autism, they often show deficits in imitation, which leads to challenges in empathy and social skills. So that's it for this lesson about learning. If you have any questions, please ask them in the comments below. And thank you for watching this lesson. If you enjoy, please leave a like and subscribe, and see you next time. Bye.